How do we relate fundamental and inverse trig functions using trig substitution? Our goal is to do things like this. If tangent is u, what is secant, or what's the inverse sine of cosine of x? So to perform trig substitution, you're going to usually draw and label a right triangle. Once you have two sides, you'll have a ratio of sides. You can use the third side from Pythagorean theorem, and then once you have three sides, it's really easy to evaluate a trig function. So let's do this with an example. We have tangent of theta is 6 squared 85 over 85. Actually, usually when this happens, I think you might remember that this usually happens when we have 6 over the square root of 85, and then we're rationalizing the denominator. So we have 6 over the square root of 85. Now let's use Pythagorean theorem. 6 squared plus square root of 85 squared equals our hypotenuse squared. So this is 36 plus 85 equals h squared. Add these two together. This would be 1, 3 plus 8 is 11. So h is 11. Now we're asked for sine. So the sine of that angle is the opposite over the hypotenuse. So 6/11 is our sine. For this one, we can say, okay, we actually know where 5 pi over 6 is. It's over here in the second quadrant. When we take the cotangent of that, that would be, we can evaluate just from the inside. We know what that is. That is negative square root of 3. Now when we take inverse tangent of negative square root of 3, remember that we restrict the domain of sine, cosine, and tangent, or inverse sine, inverse cosine, and inverse tangent, so that they're actually functions. And we restrict tangent and sine to the first and fourth quadrants. So when we're talking about negative square root of 3, we're talking about here. So what is the angle that gives us that amount? Well, that's negative pi over 3. So overall, when we take the cotangent of this and then apply the tangent inverse to it, we get negative pi over 3. If tangent of x equals u, then we have a triangle with x there, then it's u over 1. By Pythagorean theorem, we can say 1 squared plus u squared equals the hypotenuse squared. So 1 plus u squared equals h squared, and we can say square root of 1 plus u squared equals our hypotenuse. Now for secant, we'll say that that's hypotenuse over the adjacent. So secant is hypotenuse over the adjacent, which just simplifies to be that. Weird thing, where you wouldn't, just looking at the problem, you wouldn't realize it, but once you set up a right triangle with these side lengths, then it becomes very easy to do Pythagorean theorem and set up the ratio. Similar idea, let's say we have cosine of x. Let's call it u. Yeah, let's call it u. So that's adjacent over hypotenuse. And then whatever that is, we have, let's see, we have Pythagorean theorem says 1 squared equals u squared plus the opposite squared. So we have 1 minus u squared equals opposite squared. Square root of 1 minus u squared equals the opposite. So 1 minus u squared. Now we're looking for sine. So it's going to be this 1 minus u squared. Well, that's the same thing as, well, u was our definition of cosine, so we can say that this is 1 minus cosine squared of x. Thanks.